introduction also later, very short, brief.
Good evening, sir. Sir, I'm Mrityunjay. Actually, I have been present here three times, and I have heard you speaking so much about science. So, I am pursuing my bachelor's in technology in computer science. I'm currently in my first year. I'm from Odisha, but studying in Bangalore.
Very nice, very nice. So you are a man of computer science. Did you listen to me the day I was talking about electronics, how the in the transistor how it works? Were
No,
you
sir,
in that meeting?
unfortunately,
Uh,
that day I was absent, sir.
Oh, okay. All right. Okay, we'll do it some other time. We did only
Sure, sir.
basic transistor functioning that day in the meeting, and we will pick up that discussion when all the. I think there were Brenda was interested. She wanted us to discuss it, so that's when it started. But I will pick it up some other time. Now, Chaturanan Mallik has also joined, and yeah, so I don't know if everybody is familiar with everybody else or we need some introduction. Thanks, Mrityunjay. Then you already know about it that my background is in um, electronics, and I have been involved all my career here in the United States in research and development of a semiconductor, how the electrons can be utilized for practical application, and that's why that is what is the computer chips. So,
That's really awesome,
Mal,
sir.
yeah, so
Thank you for
Malik ji is
introduction.
here. Yeah, Malik ji is my friend from the childhood. We grew up, we are first grader friends, and we both have worked, interestingly, we both have worked on electron, all in our technical career. He worked on electron, how it can move in cyclotron from one place to another. I have worked on how electron can move also from one place to another. So that's something is also common in both of us. And as you know, at the high level, physics and engineering and chemistry, they all become the same. There is no boundaries between them. So discipline, you can call it any, but ultimately when you start working, and that's what the mindset I want young engineers to think about, that there is no boundary. Oh, I'm this, I'm that. No, ultimately, and that's a very good thing I saw in America. In American, I have worked in 5 6 different companies, that you have people from different discipline working together. It is not a full of chemical engineer or mechanical engineer or civil engineer, a physicist or chemist. At IBM, at Intel, at Lamb Research where I worked, at Air Liquide, at another company I worked, Lindy PLC. These are the 5 major companies I have worked in America. And every place I found in the research and development, you have people from different discipline working together side by side. It is just like a elephant and six blind men. I have quoted it. It's my favorite top quote, that there is an elephant in the room and there are six blind men, and they all experience the elephant but conclude differently. For example, one person who comes in contact with one of the leg of the elephant, he says, "Oh my God, elephant is like a pillar." That is his experience. Another one, he who experiences one of the side of the elephant, he says, elephant is like a wall. That is his experience. Okay. Somebody touches the trunk of the elephant and he says, "You guys are wrong. My experience is the elephant is like a banana tree. You guys are telling all lies. Elephant is a banana tree." So this is how the whole thing. Somebody goes on the top of the elephant, and he says, "Wow, this is a great bed. You can sleep here. There are space for 2 3 people here." So he thinks that experiencing the top, he thinks that elephant is like a floor. Exactly, that's how it happens. One thing we look at different perspective when we come to different conclusion, and so we have to realize that. And sometimes we need to collaborate that put all the experiences of everybody together And then here is the elephant in the room. Okay, with that introduction, I see some more folks here. Brinda is also here today. And Aryan is here, who is our great future scientist. So, Aryan, let's begin with your question. Mallik ji is ready to answer your questions.
Good morning, sir.
Good
Good evening,
morning
sir.
to
Sorry.
everyone. Good
Good
morning.
morning, sir.
Good evening. Good evening.
Yeah, that's okay. Good evening, good morning. Everything is fine.
Yes, yes, sir.
Hello, sir.
Acha, but only one thing, Mrityunjay, you are basically involved in what?
I'm a computer science student, sir.
Yeah, you are in Bangalore, isn't it? Hello?
Sir, am I
Yeah,
audible, sir?
Yeah, yeah,
yeah, he's,
you are audible. You are in Bangalore, isn't it?
Yes, sir. Yes, sir.
Yeah, yeah. So, right. So, So, Aryan, you're the youngest, so you can ask the first question. No, everybody is allowed to ask a question. I mean, it is just I basically wanted this Saturday should be devoted to understanding our environment, everything that we do in our house, in our school, in our office. We should understand the scientific, what do you call, the viewpoint about things around us. Whatever is around us, we should ask about it, because on this platform, you can't start making big lectures for 1 hour and 2 hour and making understand, but we could certainly take up questions which are around us, something we don't understand, we would like to understand from others. So, Aryan, you can shoot your first question.
Yes, sir. Sir, how does telescope how does we measure large distances?
Oh my god, you have asked a question, but then today the expert is not there on that. Yeah, but roughly I think last time we had a gentleman from Bangalore, no? Deepak.
yes.
Yes.
Yeah, he's an expert on telescopes, and really I wanted to learn something from him. Pankajji, he has not sent me his group, telescope group. Can you tell him to send me the telescope group? Because I have a telescope and I'm not finding a person to make it functional. So he might be knowing. He is in contact with many people here in Kolkata. Can you post his number?
Yes, sir. I
Yes,
can send
Naveen
you,
ji.
sir. Yes, yes,
Yeah.
sir. Definitely, I can send you, sir. I have
Yes.
a number, sir.
Naveen ji has contact number of Deepak.
Yes, sir.
So,
Yeah.
sure, sir.
So, Aryan, well, there are many ways to find out the distance, but what the distance is, one of the easiest ways is, we have to learn a little bit of geometry. So, what happens is that suppose there is a star. So,
Yes.
you watch the star from, say, the earth goes around the sun. So, from one side, let us say you watch the star, and from the other side, when the earth goes just after half an year, it goes to the other side of the sun. So there is a
Yes.
straight line here, and there are in a triangle now this. Yeah, Aryan, you had a question. What was it?
Uh, Sir, I have another question. Why the equation E equals mc squared have c squared? I mean light constant.
Acha, I don't know the answer to this question. Does anyone know why there is a c square? Well, of course, we know that energy always has like the mv square, mass into velocity square. So this is also a energy term. So it will be mass multiplied by the velocity square has to be there. So this is the energy actually, no, isn't it? So there has to be a c square. It cannot be c.
Mm-hmm.
Yeah, yeah. This is energy. Kinetic energy is half mv square. It's like that. So there is, but there could be I don't know, there could be a deeper meaning to this, that why it should be c square only. Well, I don't think there is a deeper, except that always the energy is mass into c velocity square.
Mhm.
Mrityunjay was asking a question. I think he was raising his hand. Hello?
No, sir, it is answer, sir. Actually, I was trying to like explain in simple terms like why do how we measure long distances. So you explain
Surely,
it,
why
sir.
don't you say so? No, no, you can say you have something to add to it. Do you want to add
Yes, sir.
something to it?
I would like that.
Yes, sure.
Yes, sir. So like
Please.
in the scale of universe, the long distances are measured by time, not by distance. So we use the term light year to measure distance, the amount of distance light travels in 1 year. And also
Right.
like sir, as you said, yeah, as you said, the parallax method. So
Yes.
in simple terms, you can make an analogy like you can place your thumb at one hand distance from your eyes, then close your eyes and measure and see that observe the thumb. Then close other eyes and observe the thumb. It'll be slight moving effect, and the distance which you measure is that's a parallax angle.
Right. Right.
Uh, yes, sir. So you can measure that way.
Yeah, yeah. Aryan, so what Mrityunjay is saying, that our eye also, by having two eyes, see, we can measure the distance of something. If we had only one eye, we couldn't have measured it. So this is actually called in geometry and also in physics parallax method, which Mrityunjay was explaining. So, but there are other techniques are also there to measure the distance. Of course, for the short distances nowadays, like for the moon, they send the laser waves and it comes back. And from the time delay, you can measure what is the distance. But there are still inaccuracies and that. But long distances like the other nebula, other galaxies, we measure by this parallax technique, and there are few more other techniques. But in general, basically, this is a parallax technique.
Sir, I
So
have a question
yes.
about the same parallax method. So that so as you have observed from like suppose you're traveling in a vehicle in a
Mhm.
plain road, and you'll be like we'll be observing the surroundings. So
Right.
if you have observed that some the objects near us will
Mm.
be traveling behind much faster, like will be moving behind, so appearing to move behind much faster, while the
Yes.
objects far away from us will be appearing to move behind slower, and some even if other objects will be appearing to move in front of us.
Yeah, and
Like
that too
why
in
does it?
opposite direction. Opposite direction.
Yes, sir.
The far object moves
So
in opposite direction.
yes, sir. Why does it happen, sir?
Yeah, I want to ask you this question. I have to think also about it.
Hey, Brinda has raised the
Good question.
question. So
Yes.
let's ask if Brinda has something to add. Brinda, go ahead.
Yes, but it's another question, different question.
Okay.
That's okay? You end with the question about the other person?
No, I'll have to. Yeah, this is a question. I have to think little bit.
Okay.
Maybe answer it the next time or something like that.
Okay, Brinda, if you have another question, let's hold on to that one. Let's finish this topic discussion. And I have something to add for Aryan. So, Aryan, what we have been talking so far is one medium uh, uh, use for measuring the distance, which is light. In all these discussions we are having right now, light is the source of the medium to measure the two objects, which could be close to each other or could be at a you know planetary distance. But that is not the only medium. Now science has discovered many other sources by which we can measure the distances. So let's keep that in perspective. Others are still in development. This is telescope is using only the light as a source, And as you can see, that now they have telescope in the space. The reason is that when you are in the space, it becomes a lot more easier. If you are doing it from measuring from the planet Earth, these all celestial objects, how far they are away from us. Uh, mm, One way, and you have to do the mathematical deduction of the distance and the rotation of the Earth and all that. But if you are from the space, there are certain advantages because there is no atmosphere there, and there are few other advantages. That's why, like Hubble telescope is in the space, and it has measured for it has served our humanity for such a long time. And again, the light is the medium for Hubble telescope. I don't know if you are familiar with the convergence and divergence of the light. And if you are, then basically you can understand that I should give, yeah, yeah, that is what is it is using to measure like when the Big Bang started and all that. Any more
Yeah.
discussion on this topic? Please say something, everybody.
So Aryan, what about the Chandrayaan 3? What is the status?
It is
Oh,
going to
no, but
land on the moon.
let's take up Brenda's question before
Yes,
going
yes.
to another guy. Yes, yeah.
Yeah.
Oh,
What is
thank
your
you. Yeah, actually, we have limited resources. Many in the air. Many of them are running out. But I see different notes in the news about the NASA is trying to development machines for um, extractions, minerals or different materials in a moon. Is possible stolen, well, the science or the members of the NASA and others projects stolen the resources on the moon and happen the same in the air, um, and with the resources and minerals, different materials in the moon. I
Yeah, it
guess.
is true. The present race for going to moon, all these few years, no, they stopped going to moon. It was only in 60s, 70s, and there were moon missions were there. In fact, Russia is launching after some 70 years or something like that. Now, the interest in moon has come for two reasons. Basically, one is that from moon you can launch vehicles to other planets very easily because the gravitational force is less. So you will need, you see, most of the all the weight of the rockets, they carry fuels just to go out of the gravity of the Earth. Now on the moon, the gravity is less, so you can go to bigger distances carrying less fuel and all that. So all countries are thinking of launching vehicles from moon. Of course, that is a far dream. The second is that it appears that moon has a lot of resources. So one is extracting metals. I think the Elon Musk proposals are mostly related to that. That let's go to moon and bring things from there. Now nobody knows how to bring so much. Suppose you have to bring even 1 ton of material. How to bring that? Nobody knows it. So there are a lot of materials on the moon which can be utilized here. One. The second is one very important thing which is there is helium-3. Now, helium-3 resource on Earth is very small. And helium-3 is utilized in superconducting materials. So,
Yes.
in
Let's.
cryogenic materials.
Okay.
No,
Hey,
yes,
I sent the link to Srinath Thakur, one of our friends. Sorry, let me mute it
yeah.
first.
So, has he
And
come or not? No, I don't see him yet. So it is the helium-3, which is a gas on Earth. There also it is a gas. It seems there is a lot of helium-3 on the moon. But everything is dependent on whether there is enough water or not. Suppose you go and do the mining People have to stay there for some time. You need a house to stay, you need food to stay, you need water to stay. If the water is there, then you can get oxygen, you can get hydrogen, so all which can be converted to fuels and all that. So finding water in large quantity is the primary goal right now of all the moon missions now. The India which it has sent is also the one of the main thing is to finding out water. Same is with the Russia. Russia, in fact, had sent, and probably it may land on the moon 2 days before that. This goal of this is also to find water. And other missions are also there, which will come from China and US. So extraction can be done only after these things are met. No, people are thinking, but nobody knows. Suppose I have to bring 1,000 kg of, let us say, suppose I find nickel or gold or something. How to bring it from there to here is a question. But then people think that it will be possible. You see, we are all greedy people, isn't it? Isn't it, Brenda? It's, we are also greedy that if we find gold there, we'll be very happy. Ladies will be more happy, isn't it? But it is a lot of nickel. There is a lot of nickel and composition of this where the Indian moon mission is landing. That also has got very special characteristics compared to the equatorial moon. So let us see. People are just hopeful. Main thing is first water. You need water there. Somehow big ice chunks should be there so that we can survive there.
Yeah, but different projects for go to the moon. I think they have a different contracts, or it's possible. I don't know. Russia recollect if found gold. It's possible they recollect all the gold and carry on to the earth. It's possible, or they have a contract in different terms.
No, no. So sorry. No, no, no. No. When carrying gold from moon to earth, you're asking?
Yes. No, no, no.
Yeah, yeah. No, no. I sorry, I didn't get your question.
Okay. One example: if the science found gold
Yes,
in the moon, gold in the
yes,
moon, okay,
yes.
it's possible. One country like India recollect all the all the minerals or all the golds. It's possible to go with this material to the air and try to mining all these resources like a stolen.
Yeah, you have raised a very good question. This question is being asked many times.
Just
That
because in the moon we don't have a camera and
yeah,
I
but
don't.
what is going to happen is that, see, whichever country goes there will have the right to mine. Basically, now there are no agreements between the countries. So whichever country will go there first will start mining there if it can do the mining. And some international agreement will come, but they will try to occupy places. They'll put a boundary here. This is mine. This is mine. Things like that may happen, as
Yes,
it happened for Europeans in USA.
just because I don't remember well, but Pankaj mentioned the other day, um, many countries purchase part of the moon. This is true.
Many countries.
Purchase part of the moon, like at the air. You pay for one part of the land.
Oh,
Oh,
that is there, but that is all joke. I think don't believe in that.
yeah,
And there are many
yeah,
fake companies. They are asking, give money, will sell you 1 square kilometer of land on moon. First of all, they
yeah.
don't have any right. There is no right now. There is no country has right on the moon. But what is going to happen? The whichever countries goes first there will certainly acquire some mining rights. In fact, people say China is ambitiously doing this project in mind, actually. So, but nobody knows actually right now. Some
Yeah,
international agreement will come that how the sharing will be done. And
Oh,
obviously the countries who go there will have the major share.
it's free now.
y-
Nothing
Now it is
purchased
free.
part
Now
of.
it is free because nobody can mine right now, isn't it?
Okay.
yeah. So, Brenda, to add on this one, that there are two aspects. One is humanitarian, and other is greed, right? So, for example, right now, if you take the example of the ocean is 200 miles boundary is any country's vicinity. After that, ocean is a international property. But as you see it, that on our same planet where we are living, everybody is violating it. For example, China is currently violating in South China Sea, and it's claiming that it's theirs, and for that reason, other countries are resisting, and most likely you might have a war in future sometime because there are 6, 7 countries, nine dash line they have created China, and everybody else is saying that no, it is a violation of the international ocean law. So that's one thing. You already see that how the Western European countries colonized us Asian countries as well as North and South American countries on this planet. I mean, so morality and greed are the two different things. So the fight will continue until there are two human beings present on this planet Earth for the full control of the whole thing. Unfortunately, I don't know why our brain is wired such a way, weird way I call it, that we want to have everything for ourselves. We don't want to share, and that is causing all this grief now, and will cause in the future. Probably that will lead us to war one day and will destroy the whole planet, and then that will be again, we'll start all over again. So yes, your concern is very valid, but unfortunately there is nothing much we can do about it, especially now.
Okay. Thank you.
So this helium-3, you all might be aware that on Earth, in future, it seems the superconducting technology is going to play a very large part. But superconductivity, people are looking for right now. Say, let us say you might have heard the CERN, where the God's particle was discovered. They use magnets which are all superconducting and they consume a lot of helium-3. But helium-3 is very, very, very expensive. Helium-3 is isotope of helium-4. So helium-3 is very expensive, and we don't have a big resource of helium-3. But on moon, it seems there is a lot of helium-3, all trapped in the rocks. So people are very, I mean, in case we run short of helium-3 here, people are thinking how to bring helium-3 from moon to here, because the superconducting technology is going to grow very fast. Very soon you will be having a lot of things which are superconducting. Superconducting, I think everybody understands, isn't it? What is
Yes, sir.
superconducting? Aryan, do you understand what is superconducting?
No,
Hello?
sir. No,
No,
sir.
superconducting is, suppose you have a piece of wire, so it has a resistance. So, but a superconducting wire has no resistance. So suppose in a wire, no, you start flowing current, that current will keep on flowing forever. Can you
Oh,
imagine that?
that's
What
good.
a, what a nice thing that is. And this superconducting, we in India, well, I was the project leader of that superconducting cyclotron in India. We constructed one cyclotron built with superconducting magnet. And we used, of course, helium-4. So helium-4 can be used, but if I want to go to still lesser temperature, that is minus 269 degrees centigrade, minus 269 degrees centigrade, I need helium-3. Here in Calcutta, we went to helium-4. Helium-4, which went to minus 267 degrees centigrade. So the cyclotron of which I was a part, yeah, we went to minus 4 degrees centigrade, minus 4 degree Kelvin, that is to 267, and one is 265, like that.
Okay.
But we need to
Sir,
go still lower temperatures. But people are finding room temperature superconductors. So the future, recently there was, I don't know whether you all read newspapers, there was a research group, they said that we have found a room temperature superconductor. Means at room temperature, it is a superconductor. And what we
okay.
get at minus 269 degrees centigrade is happening at room temperature, but it was all wrong. They were just, it was a fake news done by the scientists to get popularity, but it was a wrong news. It has been proved wrong. I don't know, it came in the newspapers in India. I don't know whether you all read it.
Uh, uh,
Its
uh,
name was LK99, sir.
Hello?
Its name was
the-
Sorry, you sound, your voice is not clear. Please, once again.
Yes,
uh,
Mridunjay, please.
sir. Am I audible now?
Yeah, now you are.
Yes.
So its name was
Eh,
LK99.
Exactly, exactly. So it's a fake thing. Don't believe in that. So that group said that we have done it, but when other group tested on it, they said that no, it's not true.
uh, sir, can I speak about
Yes, yes, yes.
okay. Uh, classical phy- physics was also known as the most beautiful theory uh, around 16th or 17th century. It, it describes the motion of objects on Earth and in our everyday experiences. It is based on classical mechanics, which includes Newton's law of motion and the law of gravitation. This theory was
No,
extremely successful. Sir, I
no, no.
have
One minute. In
prepared
16th century, there was no. It's the no Newton. Newton has come in later, isn't it?
yes, sir. Sir, whose 16th or 7th, it was the most beautiful theory during that time. Or else maybe I have written wrong here.
Hmm? Sorry,
Hmm.
once again. No, your sound is not clear, Arian.
Yes, sir.
Huh? Your voice is not clear. Please, once again. So you said 16th, must say when the Newtons came, so that was a classical mechanics. Yeah. Then after that,
It was a very successful theory for many years. However, classical physics began to face limitations when scientists started exploring phenomena at the microscopic level and the behavior of objects at incredibly high speeds. This situation were beyond the scope of classical mechanics and required uh, theoretical frameworks to accurately describe the observed phenomena. One of the first cracks in classical physics appeared with the advent of electromagnetism, which could not be entirely explained using classical mechanics. The classical electromagnetic theory, proposed by James Maxwell in the 19th century, contained four fundamental equations that beautifully described how electric and magnetic fields interacted with each other and with charged particles. Maxwell's equation revealed the existence of electromagnetic waves, including light, and laid the foundation of the theory of optics and electromagnetic radiation. This marked the beginning of the field of electromagnetism and led to realization that classical mechanics alone could not account for all natural phenomena. Another major blow to classical physics came with the advent of quantum mechanics in the early 20th century. Scientists studying the behavior of particles at the atomic and subatomic level observed strange phenomena that challenged classical concepts such as the uncertainty principle. Quantum mechanics provide a new framework that accurately describes the behavior of particles on the quantum scale, revolutionizing our understanding of the microscopic world. The theory of quantum mechanics is very successful in explaining phenomena such as the wave particle duality of particles, the probabilistic nature of measurements, and quantum entanglement, among others. Additionally, classical physics failed to describe the behavior of objects traveling at speeds close to the speed of light. Albert Einstein's theory of relativity, developed in the early 20th century, expanded our understanding of space-time and gravity. It demonstrated that classical mechanics and classical electromagnetism were incomplete when applied to situations involving high velocities and strong gravitational fields. According to the theory of relativity, the laws of physics remain constant for all observers in inertial reference frame, regardless of their relative motion. It is It also incorporates the system of space-time curvature, explaining the nature of gravity on a cosmological scale. Uh, I was talking here. I am talking about the fall of classical physics. While right now, uh, while classical physics is still highly applicable and useful in many practical situations, its limitations in the quantum realm and high speeds necessitates the development of new theories like quantum mechanics and relativity. The failure of classical physics as a complete description of the universe is not a flaw of criticism.
Oh,
Uh, in here, I was talking about the fall of classical physics.
yes. So, Aryan, every line that you have said is it's a good lecture you have given. Now it's your duty to understand each and every line that you have spoken. That will make you a very good scientist. You have, in fact, briefly summarized the how physics has developed. But someday, every line that you have spoken, I'm going to ask you questions on that. Every line, every
Yeah.
word. So you must devote a lot of time to understanding each line that you have spoken now. Do you
Oh,
understand each line of them?
yes, sir.
Yeah, that is science.
I
What you
hear
have
you.
spoken now is the brief summary of science in last 300 years. So now you have to understand each line, what they mean. But one thing I tell you, Chandrayaan, when it has gone to moon, it doesn't use any relativity theory. It just uses the ordinary Newton's law. All their
Yes,
softwares which they have got in Sri Harikota, and there it's all Newton's gravitational law which
yes,
they
sir.
are applying. So for big
So,
objects, there is no problem. It's only when we go to smaller and smaller objects of
yes, the
atomic
quantum field
dimensions,
and high speeds
the
of.
Yes. So each line that you have spoken, you must try to understand each and every word. Very nicely you have spoken.
Okay. Okay.
So everybody is waiting now for a moon rocket to land on moon, isn't it?
Yes, sir.
Yes, sir.
If everybody agrees, yes, that should be the topic of the evening, right? Because we all are eager to know what is happening. So maybe you can give us some uh, information, since we are lucky to have you, a great physicist among us. So tell us what's going on, and when is the prediction to land, and what are the pros and what are the cons?
Now,
And
yesterday they have declared it's going to land on 23rd at 5:45 p.m. In fact, it is 5:42 p.m. So in India, at least we all will be awake at least to see it. Now, uh, yeah, maybe not today, but maybe someday on details level. Everybody should learn a little bit. Then we will discuss all the things. But now I think the last maneuver will be done on 20th. Today is 19th, no? Yes. So tomorrow they'll be doing the last maneuver to decrease the radius of the lander, and so that will go to something like 30 kilometer from the moon's surface, and that is tomorrow. I think tomorrow they will do. By this, what they mean actually, this maneuvering is what? It is reducing the speed. So when you reduce the speed in a gravitational field, no, the radius decreases. So it's very simple. So science is very simple by the way. So this is what is going to happen tomorrow. And also, uh, one thing I didn't know with yesterday or before yesterday, they were discussing, it seems the Chandrayaan 1, which was moving around the moon, they have spotted it. It was spotted by the NASA team actually, still moving around. So a lot of spacecrafts are moving, going around the moon actually. Actually, this is going to stay there only for 15 days. Now, people in India, in newspapers, if you read, they are saying that Russians are going 2 days ahead. The question they are asking, why Russians take less time and the Indian rocket has taken so much time. So that those explanations have been given in all the newspapers and in the TV channels. So plus the Indian payload is twice that of Russian. It's very heavy. The Russian mission is very light. So there is a mass problem also. And plus, the rocket which India is using is not that powerful as, let us say, compared to the what the Russian rocket is. That also is there. It's the thrust which it can develop much more. Russian one. So India is now also, planning to have a rocket whose thrust is much more, and that is keeping in mind the mission to the Mars. So Indian
Sir,
space team, yes,
sir,
yes,
it took
Aryan,
more than 1 month.
more,
It took more than 1 month
right, exactly,
to
exactly,
reach it.
because it followed a technology way of going, which
And
is a very deep. First, go around the Earth, then you go around the Moon in a larger radius, then gradually reduce the radius. So, and this way it uses less fuel, compared to what the Russian rocket is used. So,
So, sir, maybe financial issues is also not, sir. Some differences is financial.
but the finance is very different. Ours is something like 600 crores, and I
Sorry.
think the yeah, Russian mission is something like three times more or two times something like that. Use.
Yes, 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 sir.
Yeah, it is expensive. So India is always finding a cheap solutions to all these problems. Even in reactor technology, no, India has got now solutions which are very cheap compared to other countries. So, so,
Yes,
so,
Brinda.
Brenda,
Yes.
I think how did the storm go ahead in India? There was a lot of news that
Yes.
Mexico is going to face a huge storm.
Yes, this is true. One hurricane
Hmm.
touched the state. Here is a Sunday in the
Hmm.
night. Touched the part of the coast. We are waiting for heavy rain in the afternoon.
Yeah.
Yeah, I have one question about the Chandrian tree.
Oh,
Um,
yeah. You can
yes,
pronounce it Chandrayaan 3. Very good.
eh,
Nice.
you can explain more about what Chandrian tree go to the moon uh, with a circles and not directly to the moon.
So, sorry, once again.
Yes, Chandrian tree go go to the moon not directly. Go to the moon in circles around on the
Yeah.
earth. And what is the reason or what is the purpose why don't go
No,
to
what it does is basically, so first the rocket went round the Earth and then increased its radius, where it started moving more and more towards but still moving around the Earth. So when that uses less fuel actually, you know. And then when the radius became large, then it made a slight change and then started orbiting around the moon. And now the rockets were fired in such a way that the radius decreases. Basically, they call it deboosting. You might read in the newspapers. So deboosting was done, and so that the radius decreases. So in this way, the fuel used is very small as compared to a Russian rocket, which has gone. So that's the main reason. So we have Mr. Pathak is also there. Amarnath ji, Mr. Pathak is also
Yes,
there
yes,
in
yes. I
the.
was I was going to interject you that Pathak ji has joined after a long time, and we should.
Now he's left, sir. Now he's left.
Okay, all right.
yes.
So okay, when he comes, then let's give him a chance.
Yes.
Applause.
Pankaj sir,
He
please
will
put
join
the
back.
message to Pathak sir, na? He will join again.
Yeah, maybe
Yes.
Pankaj, you can do that.
So Aryan, you have any? You can add something in Chandrayaan 3.
Mm, yeah. Yes, but everything. Mm,
Yes, Aryan, you have any question or you want to say something regarding Chandrayaan?
yes, voice is not coming.
Why is it not? What is the question? Sorry. What? Aryan, what is the question? Sorry, once again. No, you are on mute.
I think
Hello.
some background noise, I think. That's why the reason they they mute. Aryan, yes, Mrityunjay, you have any question? You want to say something? Mrityunjay?
Yes, sir, actually, I was having some problem with the mic. Yes, sir, I have a question. So since Chandrayaan 3 has a instrument to measure the, I think, Earth's spectrum about like what is the chemical composition of the Earth that it supports life. So, sir, that does ISRO have any plans to search
Can you
for
hear me?
life elsewhere in Earth?
Life on Earth, life on Moon.
So, elsewhere, yeah, life elsewhere, elsewhere than Earth.
No, 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 no. It has a spectrometer. Spectrometer is something, you analyze what is the composition of anything. So Chandrayaan 3 has got a spectrometer by which they can measure the masses, different elements, so that they want to know what is the composition of things there. But I haven't heard that if they have any plan to, I don't know how they can do it for some other planet. But see, we want to know the composition. So first thing is that we need to know the water content there. That is very important. And of course, the spectrometer is there. It will tell us what is the composition of anything, because that rover is going to that rover which will come out is going to also dig a little bit, and the spectrometer will be utilized to find out the composition of that.
Yes,
So
sir. Uh, yes, sir.
yeah,
Carry on, sir. Carry on.
yeah. No, yeah, no, no, please say. Yeah, that is, I have completed. There is a spectrometer is there to find out the masses of different elements there, so that they can identify which elements are there.
Yes, sir. That only I'm saying that since ISRO is studying the Earth by analyzing the spectrum of all the elements.
Hmm.
Does ISRO have any plans to explore life elsewhere in other planets in the future?
No, in the future, all the countries have it. Everybody wants to know if there is. Everybody wants to know one thing, that whether we human beings are the only ones in the universe, or there are some more people somewhere. Everybody is interested, not based on the nationality, but anyway, anybody, or every human being is interested to know about it. If there is
Yes, sir.
some life somewhere else, what it will look like, so many movies are there. Everybody is trying to find out what is a UFO, and all interested in finding out if there is a life beyond Earth. So that will be always there. All countries, when they send a mission somewhere, that idea is always there in their mind, that somehow to figure it out.
Sir, can
Yes,
Malik sir?
yes, sir. Yes, Aryan.
Sir, can I speak about Chandrayaan 3?
Yes, sure.
Okay, sir. Chan- Chandrayaan 3 is launched by ISRO. ISRO has big headquarters in Kan- Karnataka and Bengaluru, and the Chandrayaan 3 was launched on 14th July 14th July, and Chandrayaan 3 is a Indian third lunar exploration mission that is being developed by the Indian Space Research Organization (ISRO). It is a follow-up mission to the Chandrayaan 2, which had a partial success in September 2009. The primary objective of
2019.
Chandrayaan
2019. Yes.
yes, Chandrayaan 2, September
Yes.
2009. The primary objective of Chandrayaan 3 is to land a rover on the moon's surface and conduct various scientific experiments. The mission aims to further explore the lunar surface, study the composition of the moon, and better understand its geology and exosphere. Chandrayaan 3 was initially planned to be a joint mission with Russia, but due to certain issues, Russia pulled out of the partnership. However, ISRO decided to go ahead with the mission independently and has been working towards its development. The spacecraft for Chandrayaan 2 will be similar to Chandrayaan 3 will be similar to Chandrayaan 2 with some modifications to address the shortcomings of the previous mission. Similar to the Vikram lander of Chandrayaan 2. The launch of Chandrayaan 3 was delayed multiple times due to various reasons, including the COVID 19 pandemic. The current estimated launch date for late to 2022 or early 2020. Chandrayaan 3 is a significant mission for India as it aims to further enhance the country capabilities in space exploration and scientific research. It also showcases Indian commitment to space exploration and its ambitions to become a major player in the global space community.
Very good. Thank you.
Anyway, uh,
So, what happened? Aryan, you have got a dog in your
sir,
house, isn't it? You have got a dog in your house, no?
no, sir. There are there are street dogs and mm, cars.
Hmm.
Sir,
So,
first of all, it
so
was
now it is.
a joint
Yeah.
mission.
So I have one question for Amarnath ji.
Good.
Hello.
Yeah,
The
I'm
ques-
listening.
yeah, I'm interested to know what is this cheap, no? 1 nanosecond, 2 nanosecond, 3 nanosecond. What is this technology? What is this people are talking about?
Okay. So there are two
Atomic
things there.
clocks.
Aryan, you want to answer this question? It's not actually nanosecond. It's actually nanometer. Okay.
Yeah, sorry.
So
Yeah,
Nanometer.
yeah. 1 nanometer. Right.
okay.
Yes.
All right. Okay. So
So
Brinda was
what is the challenge in this one actually going for 1 nanometer? We all would we want to know whatever we know is a general thing, but what is the you
yeah,
have worked on it, so we
yeah.
are asking you.
I guess let me share it on the screen. That will be a little bit more useful for everybody, especially for Aryan, because I want Aryan
And
to
also
understand it.
for Mrityunjay also, he is doing computer
Yeah,
science.
yeah. So
Yes, sir.
Pankaj, can you please share that file on the electronics?
Yes, yes, sir. 1 minute.
Okay, just to go to, I think it is the second or start it from the beginning, um, and then we can go to the source and drain file. That is where I want to discuss. So while he is bringing the presentation, which one day I talked a little bit about, I just want to give a general introduction that electronics is not a very old industry. It is only started in 50s. Can you believe it? It's just how young this industry is, younger than the car industry and other industry. And so basically, if I take the uh, okay, good, it has come. So let's go to the. I'll go directly to there instead of going directly. I'll just go a little bit of background. So semiconductor chip manufacturing, basically this research patent started happening in 50s and 60s. And then as you know that first something is developed in physics in lab, and it was done in Bell Lab in New Jersey, where I am right now living. And there was a huge Bell Lab. It was very popular in this area. And then after that, anything in the science, in physics, first when something is developed, then you start doing engineering on it, how to make use of it for making money and public use, whatever the motive may be. So that is what we call manufacturing development for making money or monetization. So that started in 60s and 70s. And then really the productization happened in 70s, late 70s and 80s, when really people started making money out of it. And then it has got into the suddenly multiple application, and now you have pretty much everywhere. You cannot think of a machine including the artificial intelligence or Chandrayaan or lunar 25, whatever Russian has on the space right now, or anything you can think of. Every machine, artificial machine, now need a computer chips. So this become a kind of fundamental thing. Let's go to the next slide. Okay, so here is the very first research happening, just like Chaturanan Mallik has been doing in the lab. You see, this is the first patent being developed. That is the picture you have. This is the story of the first patent, how the physicists are working in the lab. Go to the next one, and you guys can read it later in more detail. Okay. So what I am showing you, a cross section of the transistor. Can you make it a little full screen, this one? Bigger? Is it possible? Any more bigger? Okay. While he is working, he is trying. So if you look at it, I want your attention at the bottom of the picture. See the bottom of the picture. Go to the bottom of it, please. Little, no. Previous picture. Yeah. Okay, stay here. This is good. So what I am showing you in this picture is think of a multi-story building in Bombay, Bangalore, Delhi. Okay, computer chip making is not any different from building a multi-story building. Okay, now another common thing. What do you need for multi-story building? You need sand. We also need sand for making computer chips. So that's the second thing common. And then you need a common sense and how to manipulate the common sense into engineering. And that's how we do it. So what is happening here is, just to give you a nutshell, I'll give more detail in another slide. You see you have three different colors here. At the bottom is one section. What is that? Green color? I'm very, yeah, green and blue. Then you have kind of yellowish, different flavor, and orange, another section. And then third you have in red and what is that? Blue or green? What you call it? I'm getting confused. Red areas. Okay. So there are three different activities happening for the computer chip making. And then once we are completed, then this whole piece goes in a module which talks to your computer or your phone. Okay, so let's see what is happening here in the bottom. If you look at very carefully at the bottom part of the picture, I'll come in more detail. I'm giving you the over bird's eye view. That is where first we make the transistor. And in the semiconductor production, we also call it front end. You'll hear. And the transistor, Mallikji has asked a question is, what is that 1 nanometer, 2 nanometer, 3 nanometer? So I'll come to that. But if you look at in the bottom section, there is a picture there in the very first picture you see in like blue water. And after blue water, there is a picture just like you have seen in your village. If you have seen any river, breeze on the river, um, something like that. There is one thing is up and bottom is like water, ocean. So this is where exactly is the main computer transistors are built. Then once the transistors are built, then you need to think how are you going to connect to the world. That is what is the whole thing is done from the second layer I showed you, middle of the line we call it, the third layer, which is the interconnect. So the bottom is transistor making, middle layer is kind of think about different mechanism how to make it useful to transfer to the real world. And third section, the red one which you see, they are nothing but all different coppers. There are different level of copper applications so that connection is happening to our world. So just like in the physical world, you need copper to connect. We use transistor in the within this transistor, which is so tiny that you cannot see it. Even that we do the electronic wiring by using copper. Okay, next slide, please. Go to the next slide. It hasn't come yet. Down. Maybe I don't know how it is, but it is taking a little longer because this is the.
1 minute.
Oh, it's coming. Okay. All right. So this is the slide. Stay there. And Bowenji, the bottom part is for you to read it later. The physics, device physics. That is for you and me to talk about it sometime in more detail. But we'll go to only the picture part. Okay, the top one. So focus on the source and drain part. Go a little bit so that I can have that one for everybody. And that will answer the Mallikji's question. No, oh, sorry. Yeah, this is good enough. Can you focus more just the source and drain part of the picture, which you have in the picture, the front, the top portion? Okay, yes, perfect, perfect. I got it. Oh, it's disappeared. Okay, now. Okay, so I was giving you an analogy of the bridge that imagine that there is a lake full of water, and then there is a dam, and then there are canals on the other side. So let us call the lake river water as a source, and let us call the canal system on the right hand side as a drain. And then you have a sluice gate in the bridge you have seen on the dam. Like here we have a Uber Dam. There are hundreds of dams in this country and all over the world. And so there is a sluice gate in the dam where you control it, that sluice gate, to discharge the water. And everybody has, if you have not taken a tour of that, anyone, every country has a dam, you should. Okay, so that is what is happening, how you manage with the water. Now the same application now we have, think about is a lake of electron on one side of the dam. And now we want to move that electrons from one side to our canal system to make it useful to irrigate our field, or you can call it all our home computers, all our telephones and all that. So that is the electron need to come on the other side to power all our systems. That is the drain part. Okay, so how do we do it now? And that we want to do it at our will. Whenever we want to turn it on, we want computer to turn on. Whenever we want computer to switch off, it has to switch off. So that is the power we have to have in our control. Okay, so that is exactly what we are showing you in this picture in the case of electron. Okay, so source has all the electrons, and your goal is to take the electron from the source to drain. Okay, so how do you do it? That is the question, right? So what we do is that we start with the silicon. Silicon is Si. If you go on the periodic table, you will see, and Malik ji can explain a lot more better, that its outer orbit had 4 electrons, and you know that for a stable atom you need 8 in the outer. So what is happening if you have a source of silicon atoms in a big mass? They are stable. You see the sand all around us, and actually it is SiO2. But let's just focus on Si only. Or then the outer orbit of it has 4 electrons. They are sharing those electrons with other 4 silicon atom around it, and that's how by the valence bonding now there are 8 electrons in the outer orbit of each silicon atom, and everybody is stable, happy, enjoying the life. Now, our job as an engineer is to disturb that peaceful environment. You know, that's what we do. And so, if we disturb that peace, the stable atmosphere of the silicons, then we can make good use of that. That is exactly what we do. And for doing that, what we do is that silicon atom is that, think about 5 silicon atoms, which has outer electrons, has 4 atoms in it. What we do is that we implant a boron atom, or you can implant a phosphorus atom, and you disturb the environment. Okay, and then when you disturb the environment, what happens is that now if you are doing it boron, phosphorus, let's begin with the phosphorus. Phosphorus has 5 electrons in the outer orbit. So what you have done, there are 5 group of 5 silicon atoms. In the middle of that silicon atom, which was, you have replaced it now by a phosphorus atom. Now, what happens? Now, phosphorus has a 5 electron, so 4 will share with all the neighboring 4 silicon atom. But what about one extra one? That is what now you have the power. Now, this extra electron which you got, you manipulate it to go anywhere you want. And when it moves, that is what is utilized in this picture, which you are giving you source drain picture, to move from one place to another. And then when it's moving, we call it on condition. When it is not moving, it is off condition. And that is the control you have. Okay, so now that is the atomic physics. Now let's go to the source and drain picture. So you see between source and drain there is a channel here. We call it channel. Okay, and in the top you have is electrode. So as you know that if you want to throw electron from source to drain, let's say that both of them are conductor, and there is a gap here right now. So you need to bridge this gap. You need to bring a conductor in the play, right? Then only something from the, let's say the source is also conductor, drain is conductor, but in the middle you have a insulator. There is no electron flowing it. So what our goal is, that this insulator, which is also the bottom part of it, we want to make it semiconductor. And how do we make the semiconductor? We put a voltage, apply a voltage from the top. Then this insulator here, which we have between the source and drain, which is supposed to be a non-conductor, it becomes semi, and then it becomes conductor. And so every time we apply the voltage from this picture from the top, then this behaves, this insulator in between source and drain, as a semiconductor, and now the electron can pass from source to drain. So there is one way of electron passes from source to drain, I showed you there are two ways. I showed you that in the case of boron, electron will pass if you do the electron boron implant one way. In the case of phosphorus, it will pass one way. But the bottom line is that now you have a transistor where when you apply voltage from source to drain, uh, and there is in between this channel width, it can flow. Now, to answering Malikji's question, this is channel length is what we have been measuring. And this channel length, it tells you that if the channel length is bigger, wider, your more electron can flow. Uh, and if it is smaller, of course, less electron will flow. So this is channel width is very important between the source and drain, and that is what we measure in the device physics, and that is channel width is measured in nanometer. We started in initially in the micron level in 80s industry. When I joined in late industries, it was not even the nanometer. Then it started going down, and I was up to 7 nanometer development in this industry. So basically, there was you higher. We keep coming down. So, for example, 32 nanometer was a kind of industry standard right now. Everybody, all the type of industry, say for example, Micron and memory industry, all kind of microcontroller, they use like 32 nanometer, this channel width here. So, and then the CPU, which is the brain of the computer type of transistor, they are now in the range of anywhere from 14 to 3 or 2 now. So I'm coming to that development. So in the late 90s, IBM Microelectronics was the leader of the semiconductor development, this piece, which I just showed you. And I was lucky enough to work there, and so come up in contact with great physicists and device engineers and blah blah blah. So what happened is that in the 90s, IBM trained everybody in the world, all who you can think of, like Samsung, Intel, TSMC, Siemens. And when I was working there, it was a consortium of IBM, Toshiba, Siemens, Samsung. The engineers from all these companies were working at IBM. It was a consortium research lab where we all together were developing the transistors, which I explained to you, 64 meg DRAM and then 256 meg DRAM, where we have all partner engineers. We all were working together in group meetings, and we are developing the earlier transistor incarnations. You can imagine I'm talking about 90s. And the goal was that IBM, whatever we were all together developing, every company has the authority and power to use that in their countries and their companies. So jointly things were developed, and then it started going all over the world. Then IBM decided to back off, and for whatever politics, whatever reason it was, or they were not making enough money, because this industry is very heavy capital intensive industry. So they decided to pull off. They started but they have already trained other industries and other people. Like in America, you have Intel. In Asia, you have Samsung, TSMC, Toshiba. So they kept the ball rolling. So now coming to later on. So now you see that this source and gate development, there are only 3, 4 development really has happened big. I want to kind of highlight that one. So now the question comes that source and drain, I explained to you that what is channel width. I'll take a pause to answer questions first at this point from all of you.
Oh, I think you can go ahead and yeah.
Finish? Okay. All right. So now, as I said that in the sluice gate, when you are operating a dam, you know that if you increase the sluice gates higher, or if you have 4, 5 gates there, Sometimes you need to open only one gate. Sometimes you need to open all five in the summertime to get the more water from the source to drain. Exactly the same technique we use it here. So our engineering challenge has been, how can, because everybody, like, nobody likes delay, right? We want everything at the moment when we want. So everything which we are thinking, we want computer to execute that right at the moment without any delay in microsecond or nanosecond. So it means that we need speed. So computer has to speedily execute, and it means all the billions of transistors have to execute faster and faster. That's what we're demanding every day. So the challenge was, how do we keep increasing it? So basically what happened is that if we manipulate the channel width here in different ways, so that this can imagine that it is a, a, a sluice gate 1 to the power n. Some, you can keep increasing its capacity to become bigger and bigger, or 2 to the power n, 1 to the power n will be nothing, right? You want to double, you want to quadruple, like that, so that more and more electron can flow. And in that process, fundamental physics remained the same. Only the gate which we have, over the period we have changed it, and gate making. So here I'm showing you source, drain, and gate on the top, and channel width. These are the four basic important thing of the transistor. Again, source, drain, channel width, and on the top is the applied voltage or electrode. I mean, whatever you want to call it, um, voltage. Now, so this is the classical, just like we're talking about classical atomic device physics. Now, later on, it was not sufficient. It was kind of slow. So, how do we increase the channel width? Has come to, we have started using an Intel. Actually, again, the physicist did in the lab, and then Intel kind of put it in the mass production, and that is what is called FinFET. But I don't want to go into detail, because it is just to accelerate the flow of electron transfer. So that is something not very important for all of you right now to but all I want to tell you is that when that happened, then after that we started working into, like, we came down. We used to be in the micron channel width. Now we need only 22 nanometer was the first time we introduced the FinFET technology. So imagine that channel width, now you need a smaller channel width. Now, if you need a smaller channel width, what is the advantage of it? First thing is that your speed has increased, you can drastically. And second is that where you are able to fit, say, for example, only 100 chips in the manufacturing time, instead of 100, now you can make 1,000 chips with the same application, same resources. So you multiplied your output. Basically, you improved your productivity drastically by doing so. So that is the FinFET, and in that FinFET technology, we started first with by the 22 nanometer. Then from 22 nanometer, we went to the uh, basically major milestone was 14 nanometer. And for your information, right now, Intel and what is Samsung, their major production is happening at the 14 nanometer technology. Then everybody started, Intel started working on 10, and basically other people, Samsung started working on 10, TSMC was started working on 10, including Global Foundries started working on 7, since they were late. And just for your information, when Global Foundry was working on 7, I was there, and Dr. Sanjay Jha was the CEO of that company for a while. So under his leader, he is also a great physicist and electronic engineer. Qualcomm, he had directed for a long time Qualcomm, but we failed in science. We, for whatever reason, when we were doing the 7 nanometer at the Global Foundry, we couldn't do it. And but my I was involved with the development and manufacturing of the 14 nanometer at Intel. I was part of development team at 14 nanometer at IBM. And then when I was at IBM New York in 2016, that is when Sanjay Jha, who was CEO of Global Foundry, he acquired IBM Microelectronics, and suddenly overnight we become Global Foundry. And then he gave us the task to do the 7 nanometer. We started working for 2 3 years, and we couldn't do it. We were behind, but in the meantime, TSMC of Taiwan, that's why Taiwan is very, very important. Taiwan was able to successfully do its 7 nanometer chips. And not only that, after that, they have been demonstrated very successfully to make 5, 3, and now they are working on 2. So that's where we are. But now we are at the end of the limitation, uh, everybody. Now, what will happen? Let's say that we'll go up to 1 nanometer. After that, this will become a classical physics again. We all have to come up with a new physics to utilize and replace this computer chip with something else. Because after that, otherwise, you will get stuck. You cannot milk anymore this device physics transistor any further. I mean, there is no way after 1 nanometer we can do in this one right now. Who knows? Maybe some new light like Aryan will come and say, no, 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 we can go even further down. So, and it's quite possible too. But right now, it appears to us that probably we are now at the end of this transistor technology, and world need to come up with another technology. Okay, that's the end of the chip making story. So now, any questions?
Thank you, sir.
Aryan,
Very nice, Amarnathji. Very nice.
yeah.
Thank you, sir.
Aryan,
Now
I don't
Pathak
see.
sir join, sir. Amarnath
Pathak
sir,
ji,
Pathak sir.
he's back. Okay,
Oh,
good.
yes.
Yeah.
प्रणाम सबों को
सर हम
मेरा
लोग,
प्रणाम।
हाँ पाठक जी, हम लोग जरा दूसरे डिस्कशन में बहुत बिजी थे, तो ऐसा नहीं था कि हम लोगों ने आपको देखा नहीं था। हम लोगों ने सब ने आपको नोटिस किया, लेकिन हम लोग वो दूसरे टॉपिक पर थे। धन्यवाद आने के लिए। ऐसे ही आया कीजिए कभी कभी, जब भी फुर्सत हो। बहुत बहुत शुक्रिया।
घर है मेरा।
और आपके आशा है कि आपके बच्चे लोग, दोज आर लर्निंग संस्कृत वेरी वेल। Oh, uh, uh, so I have a very interesting story of Sanskrit to tell associated with this. This is very interesting. Suddenly I remember it. Pathakji and everybody. So, we all know that we have been talking about periodic table right now, and we give the Russian scientist Mendeleev credit for organizing all the known metals on the periodic table based on property. There were some other physicists also tried, but Mendeleev, Russian physicist, get credit for it. But do you know that Russian physicist, he was also interested in Sanskrit. And so he had a Sanskrit scholar friend in St. Petersburg in Russia. So he used to go, they used to have party together. So when he analyzed the periodic table, he has some blank space materials have not yet been discovered, that what should be the material there. So he left those places blank. Mendeleev left those places blank. And then in one of the blank places, he asked his friend, who was a Sanskrit scholar, that I want to give some names. So why don't you suggest? So for aluminium, his friend had suggested Ekam something. Uh, so Ekam aluminium was the original name given to that blank space, and later on we filled that blank space with aluminium. Since already he has given Ekam aluminium name, so world kept. So aluminium we call it. It used to be originally given that name before it came into uh, known world as a science, as a metal. Uh, uh, that we know, it on the periodic table, it was first known as Ekam aluminium, something like that. So there is some connection in Sanskrit and periodic table also.
संस्कृत मैं इधर सर एक फिलीपींस से एक आई हैं अपर्णा जी, तो उन्हें मैं आयुर्वेद के बारे में कुछ बताता हूं। तो जब मैं आयुर्वेद को देखने लगा तो मुझे लगा कि मेडिकल साइंस में सभी किताब को हटा करके चरक और सुश्रुत की किताब को पढ़ाना चाहिए। आयु के
बिल्कुल।
बारे में, शरीर के बारे में इतना सुंदर ढंग से सजाया गया है, लेकिन सभी पुस्तकें सर सड़ रही है।
इट्स अनफॉर्चुनेट, क्या करिएगा। तो यही है। तो आई थिंक बहुत अच्छा रहा आज का डिस्कशन, काफी टॉपिक हम लोगों ने कवर किया। तो चंद्रयान जो है 23 तारीख को है। मलिक जी, हाउ अबाउट वी मीट फॉर दैट ग्रेट इवेंट टुगेदर, some all of us? Pankaj, do you think you can arrange a meeting like when Chandrayaan is ready to land, we all should be in the meeting that time watching it, and while we have this meeting going on too?
23 means it's on Wednesday. Yes, sir.
What time
Wednesday
will
evening.
so Wednesday evening your time, so that will be evening, right? So then people should be at home, not working, right?
Yes, sir.
Okay, so all of you, why don't you send I mean, you already have it, send a kind of email notice a day before that when we have firm of time, that we
Yes.
all should come, bring our coffee in this meeting and have discussion while we all together watch Chandrayaan touching the moon. That will be great. I don't know about all of you, but first time when the moon landed on when the Neil Armstrong landed on the moon, that night, Bhavanji, I was in our village on the eastern veranda in a small room. I used to use that place for my studies. And I was sick that night, but I watched that landing of the moon, of the human landing. 1969, I think it happened, right? Neil Armstrong landed on the moon. And that moment is one of the precious moments of my life, because I watched real time. I mean, I was listening on the radio that how the like you guys watch the cricket show on the radio. I was listening. I was awake. It happened in the night. I was sick, but I was with a fever. I remember it very well. One of the great moments of my life. I want you guys, especially audience, should be definitely watching that moment, because once you watch,
So Amarnath ji, that day, I think at that time, we all will be watching TV, what is happening.
yeah,
So that night we can have a special session on Chandrayaan.
yes, that will be
Yeah.
good, right?
But
So,
I have one question to Pathak ji actually.
पूछिए।
Hello Pathak ji.
जी जी जी।
अच्छा, मैं एक चीज पूछता हूँ जो मेरे न्यूज़पेपर में भी निकला है, इसमें प्रभात खबर ये सब में, कि मुस्लिम लोग भी जो है सो चंद्रमा को एक तरह से भगवान की तरह ही ट्रीट करते हैं, और हिंदुइज्म में तो है ही कि सूर्य और चंद्रमा जो है सो उनको देवता का दर्जा दिया हुआ है।
जी जी है।
तो अब जब आदमी वहां पर पहुंच रहा है तो आपका क्या प्रतिक्रिया है इस बारे में?
किस पर सर?
चंद्रमा पर।
चंद्रमा पर इधर मुझे बहुत अच्छा गीता के बारे में पढ़ने का मौका मिला। लगातार 15-18 दिन तक मैं एक अध्याय पढ़ दिया गीता पर इस बीच। तो गीता में जो भगवान अपना विराट रूप दिखलाते हैं, तो उनमें उनके जो आंख हैं उसमें से दोनों आंख में दिखाई देता है, एक में सूर्य और एक में चंद्र। और अगर हम वेद पढ़ते हैं तो वेद में हम देखते हैं कि वहां भी पुरुष सूक्त में, हम वेद में वहां पर भी मिलता है कि चंद्रमा मनसो जाता चक्षो सूर्यो अजायतो। वहां पर हम देखते हैं कि उस विराट पुरुष जो हुए, उसके विराट पुरुष से ये जो मतलब मैं कभी कभी बोलना चाहता हूं कि संस्कृत जो है वो IIT, IIM, इंडियन मेडिकल इंस्टीट्यूट, वहां के छात्रों को पढ़ना चाहिए। और इसमें इतनी सारी चीजें दी हुई है कि उस पर आप जो विद्वान लोग हैं सर, वही उसको निकालेंगे कि अरे तो सब चीज हमारे पूर्वजों ने बता दिया है। आज खोजने
पाठक
की
जी, Pathak ji, एक second, I need to translate it for Brenda because we have international meeting going on in English. So थोड़ा थोड़ा ऐसे ही बोल करके continue रखिए, but what you just said, I'm going to translate in English for other people who will be watching this stream later.
yes, yes.
And then that's how we'll आप हिंदी में बोलिएगा, हम उसको थोड़ा थोड़ा translate कर देंगे short में. So basically, what the conversation is happening is that Mr. Mallik asked a question that now man has already landed on the moon, and the moon is very respectful celestial body in Hinduism as well as in Islamic religion. And so what as a religious person, what is your thought on all these scientific activities and how the religious people in general in Hinduism or in Islamic community take it? That was his Malikji's question. And Pathakji sir is replying to that question that he has recently, and he's a scholar of Sanskrit, as you all know, that it's very important that we all should learn and study Sanskrit because our forefather, they through the meditation have touched all parts of our life, science, technology, mathematics, engineering, medical science, and in all areas they have discovered things, and we need to continue development on that path, which we have stopped right now. Second part, he said that uh, Chandra, sun and the moon, they both are very important in our Hindu scriptures. And he gave example of Bhagavad Gita and our Ved Suktam and Bhagavad Gita, that when Lord Krishna takes does his expansion of universal form, how through his eyes, moon and sun become his eyes, and then through that he is seeing the whole universe. Okay, अब कंटिन्यू करिए पाठक जी, अगला अगला फिर क्या कहने का है आपको?
और जितने भी हमारे सोलर सिस्टम हो या जितने भी हमारे गॉडेज हैं, तो वो हमें अपने प्रकृति नेचर के बारे में बताते हैं कि कैसे ये इस संसार की रचना हुई, कैसे सृष्टि हुई। और आज आप अगर उसको वैज्ञानिक दृष्टि से देखते हैं तो वह पूर्ण रूप से सत्य प्रतीत होता है कि इसी प्रकार से हमारी रचना हुई। आज हम व्याख्या उसका गलत करके आपस में लड़ मर रहे हैं।
Okay, so he is continuing that basically what is happening is right now in nut and cell, we are not really doing the analysis of science with the devotion of like public service to bring the knowledge to the world, but with a greed that how to maximize the profit out of it. And that has created tension in our society and among the scientists and among the countries. And then it is moving in the wrong direction as a humanity. हाँ, आगे कहिए और कुछ?
और जैसे कि आप लोग सर विज्ञान के विद्वान हैं, साइंटिस्ट हैं, तो हमारे यहाँ जो वेद में कहा गया है, अग्नि देवता, वायु देवता, सूर्यो देवता, चंद्रमा देवता, तो इसमें सूर्य हो या वायु हो, तो वायु को ऐसा दुनिया का कोई भी आदमी नहीं है जो देवता मानने के लिए तैयार नहीं होगा, क्योंकि वो आपको जीवन दे रहा है। अग्नि आपको जीवन दे रहा है, सूर्य आपको जीवन दे रहा है, और जो हमें कुछ देते हैं वही हमारे लिए देवता हैं। तो कहीं भी कोई किसी भी प्रकार का कोई विरोध नहीं है। और आप लोग तो जब उसका व्याख्या करेंगे तब तो सब मिल जाएगा कि एकदम सही।
So Dr. Saab, he is saying that basically there is no difference between the approach of science and religion if you think in a very liberal way. we all are trying to make our lives, human experience better. And in that process, for example, he's giving the example of the 5 basic elements, which we came to know in physics. Shiti means earth, Jal means water, Pavak means Agni, Gagan means space, Samir means air. And as you can see that in all the Semitic religion and non-Semitic Eastern religion, these 5 elements have very, very, very important role. We all respect it. We all comprehend that that is a basic material of our human bodies and all that. And so we respect that, and we analyze that. So there is no really a difference in the thinking. All of us, we need to work together and continue and appreciate each other's work. I think that's what he's trying to say. Yes, Dr. Sam, बोलिए आगे.
एक मिनट और मैं बताता हूँ. 1 मिनट सर, इसको जरा बता देंगे. आज वाल्मीकि रामायण मैं पढ़ रहा था सर. मैं इसका नंबर कोड कर थोड़ी देर के बाद मैं भेज दूंगा. राम अकेले हैं और खरदूषण जो है उसके पास में 24,000 सैनिक है और राम अकेले लड़ रहे हैं और उस 24,000 को वो मारते हैं. तो ये तो हमारा टेक्निक है कि हमारे पास में इस प्रकार का, आज भी आप लोग बता देंगे कि हमारे पास में ऐसा बाण है कि तुम जो बाण फेंकते हो वो बाण लौटा देते हैं. तो भगवान राम के पास में ऐसा अस्त्र शस्त्र मिला था कि वो जो फेंकते थे, भगवान राम यहाँ से मारते थे तो वो उनको लौट जाता था. क्योंकि तो इसकी व्याख्या आज हमारे जितने भी साइंटिस्ट हैं उनको इस पर भाग लेना चाहिए. तो और तभी यह आगे अब बढ़ेगा.
Okay, so he is giving example of Ramayana, which is the first epic of the human history. Brenda, for your information, I think we have a little bit talked about it. Ramayana period has been already established. It happened about 12,000 few hundred years back. And how they have come, I'm telling you extra than what Pathakji has said, that because in the Ramayana and in Mahabharata, whatever it happened in the, of course, Indian soil, but then whatever was the astrological situation, all the stars we see, they have been given the position of stars and all that many, many times. So for that reason, since those astrological charts of that time for different days, different battles, different events are given, now scientists have been able to comprehend them through computer and go back of that time, and then they have been able to figure it out what is the time from that time to now. So that's how they have concluded exact date of the Ramayana war, exact date of the Gita, exact date of all those events from those astrological charts. So he is saying that that is one part. Second part he is saying is that in the battle, Rama is fighting with his enemy, and he is using different techniques, which his guru Vishwamitra has taught him, special techniques. So Rama was the best student of his time, and Vishwamitra was the best guru. You can call it military guru of his time, military strategist and equipment makers of his time. So he taught Rama all this knowledge, and Rama is able to, Khardusan he mentioned, he has a big army, and he's able to single-handedly defeat them because he used different arrow and bow techniques. His arrow and bow, he could multiply the number of arrows from his bows, and that's how he killed all of them. So there were scientific discovery at that time also. We have not focused on them. और कुछ पाठक जी
और एक चीज सर, मल्लिक सर,
हाँ बोलिए.
आज मैंने एक वीडियो भेजा है अमरनाथ सर को.
मैं सबको भेज देता हूँ.
इन दैट वीडियो वो वैदिक काल का नेशनल सॉन्ग है, और ये बात मैं अमरनाथ सर को भी नहीं बताया था, अभी बता रहा हूँ कि उसमें मोहम्मद आकिब गा रहा है वो गीत.
वाह वाह. वाह वाह. Okay,
मोहम्मद,
Wow.
so
आज
so
आज कोई आज 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 95% ब्राह्मण नहीं उसको गा रहा है.
yeah. Okay, great. So he has sent me a song which is very interesting. So first I have to listen, and then I'll send all of you. And then many of them I walk in the evening. Then there is a morning in India. So Pankaj and Brinda, I see them in the morning walk time. That is my evening walk time, and then they are in the morning meeting there. So we will talk about that one in one of the morning meetings. Okay, so now I
Sure,
would
sir.
like, if I think it's getting late, and me and the Mallikji have to go to another meeting for few minutes. So I would like to say that maybe we can call it off, or if you like want to continue, you can continue inside. What do you want to do?
Okay. Okay, sir. Thank you, sir. It's a
Okay,
very
thank
good.
you.
Okay.
Mallikji, we should
Good
continue
night.
here because we'll try to go on the tutor right now and see if we can possibly see how you can go to the tutor, because we want to make sure that you join there. So do you have a computer in front of you?
No, 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 not right now. I'll do it on the mobile itself.
Okay. So you want to give a try so that we can see if
Yeah, I just will give a try and for a
yeah.
very short time. Very
So,
short
so
time.
Pankaj knows a little bit about this one. He and I had gone one day. So if you have any trouble, we'll troubleshoot with you right now. So why don't you on the side? We'll stay in this one so that we can talk and see if you are able to go there or not.
Yeah, but okay.